Welcome to the third lesson in chemical warfare lesson, the STEM careers. This one is going to be about protection from these bad boys that I probably scared you quite a bit in the last two lessons. So we're going to talk about the hope here, things that will help us if for ever any reason people are exposed to these things. So first of all, the first type of defense against chemical weapons was neutralization masks. And you know, in lab we go through so many safety precautions. A neutralization mask is the worst possible scenario, but it was I mean, as far as safety is concerned, but really the only thing they could do right off the bat when the Germans started using chlorine gas in World War I. And literally, they have a mask with chemicals soaked on it, so you're breathing in those chemicals which might have things like ammonia in there. And when the chlorine gas comes to you, you don't want to inhale it, it actually neutralizes a chemical reaction right happening here. So we know in lab we do these reactions and we have goggles and we try to stay away. We put it under a fume hood if it's hazardous to us. Imagine the chemical reaction that can kill you happening right on your face. But at that time, that was the best we could do. So these masks are soaked in different chemicals and the reaction takes place right on there. And obviously if the mask has too many reactions, it saturates with the chemical, you're going to have to turn that out, or otherwise it's not going to protect you anymore. So neutralization masks was the first type of protection. Gas masks, there's three different types of respirators. There are first the air purifying gas masks. These are rubber masks with a filter cartridge on here. So this is very similar to the one that I was issued when I was in the Navy. Advantages of air purifiers is they are the least expensive and the least complicated option. So it's pretty simple, it's pretty cheap. You get everybody to get issued one of these, and their mask will be sealed in kind of like a can, like a tuna can, and you peel it open so that the mask doesn't start reacting with just the air, so that this canister is good here. So cheap and not hard to use. The problem is any leaks or a poor fit or crack renders the mask ineffective. So if there's any leaks, if you don't put your mask on and it doesn't seal properly, if there's any leaks in here or cracks in here, then basically you got nothing, there's no hope. The second type of gas mask is a supplied air mask. The filter is attached to a battery and it's an operated canister. So you've got a canister and a battery here, and it's pushing air into your mask and it's being filtered like this. So it's air supplied. The advantages is it creates positive air pressure. Therefore, if there's a leak in your mask, because it's got positive air pressure, it's pushing air in here, gas can't come into your mask because it's pushing air into your mask, so if it's going to be blowing air out, so it's not going to allow things to go in. The only air that's getting in here has to go through the filters first. The disadvantage of supplied air filters is that the constant airflow uses up the filters faster. Because there's more airflow going through these filters will go through faster. And if the batteries die, so do you. If the batteries die, you're not going to be able to filter anything through there, so your whole life is dependent on those Energizers or Duracells. The final type of gas mask that you can use is a SCUBA. SCUBA stands for self-contained breathing apparatus, so you can have a SCUBA situation here. This does not filter the air. What it does is it supplies your own air. So there's no filter involved with the SCUBA system. It's supplying your own air, which is not contaminated. So advantage is you got positive pressure, so you're not going to get anything to leak in your mask because the SCUBA is pushing the air in, and so it's pushing out. Nothing's going to come in because of that positive pressure. And it is the safest respirator because you're not relying on any filtration. So this is positive pressure, and this is the safest situation you can go. The disadvantage is, well, the tanks are heavy and bulky. Moving around with a SCUBA tank on your back is not an ideal situation, especially if you're infantry or something like that. And also, the most you're going to get out of these tanks is 30 to 60 minutes of air. So this is very expensive. This is not something practical for people in the field. They're not going to be able to have 24 of these to last a day, and that's the best case situation. So the gas masks with the filters are a much cheaper way to go. They all have their pros and cons. So how do those filters work? Well, first of all, these filters have multiple layers here. And as air passes through the 3 layers, they go like this. So the first layer that it's going to go through is this aerosol filter. And what the aerosol filter is going to do is just going to take out large particulates. Large particulates are just going to get instantly filtered out here. Then you're going to go through a charcoal filter, and the charcoal filter here is going to really absorb those hazardous chemicals. This is going to be the main thing that's going to protect you here, and we're going to talk about the charcoal aspect of it a little bit in a moment, a little bit more detail. And then finally you've got a dust filter, and what the dust filter does, so you got your charcoal right here, what your dust filter does is prevents you from breathing any of that loose charcoal. So you got this, you catch the particles first, then you kind of catch the chemicals here, and then you can get through here. And what can get through, and then you get the particulates, or the dust. So what comes through your filter when it's all said and done is the oxygen. So the particulate filter, the pores allow objects smaller than 3 microns to pass. So pores only allow, it has to be smaller than 3 microns to pass in the particle filter. It's very effective in blocking biological agents, because biological agents, viruses, bacteria, stuff like that, spores, they're going to be larger than 3 microns. Anthrax bacteria spores have a maximum size minimum size of 1 micron. So anthrax is not even going to get through your first line of defense with a filter. Eventually though, what will happen is all these pores will get clogged. So if you've got something this big trying to get through something this small, it will block up that area, and eventually what will happen is it will clog the particle filter, and it will need to be replaced when breathing becomes difficult. So when you start to realize it's getting a little more difficult to breathe, it's a little more, because what's happening is those pores are getting filled, and so it's harder to get that air in there. So there's an obvious warning when it's starting to go. The next layer is the charcoal filter, and this is really that important layer when it comes to chemicals. It uses what we call activated carbon. You don't just put any charcoal in here, you're using something called activated carbon, and it's used to trap small gaseous chemicals. So as it goes through this charcoal, the charcoal itself, the pieces of charcoal, it's not a solid, it's a bunch of, it's a powdery kind of a situation, but as it goes through there, the gases can get stuck in that powder because it's activated. It's basically has all these cracks and crevices in there. It can be treated with other chemicals to improve absorption of specific toxins. So you can also take activated carbon and you can treat it with something so it has a greater affinity to attract specific chemicals if you so desire. Activated carbon, this is what they use in fish tanks. If you have a fish filter and water filters for your drinking water, stuff like that, this is what the carbon is. It's this activated filter. So when it goes through, when things flow through there, it catches the unwanted chemicals that doesn't get in your drinking water or doesn't recycle in your fish tank or whatnot. So very common, and it's really just that simple to even stop chemical agents. So activated carbon is a form of carbon that is riddled with small pores, and that's what we were kind of showing over there. It increases the area of absorption for the chemical reaction. So instead of just having an object like this where the outside is a surface area, if you have a whole bunch of small pores, you're getting a lot more surface area that's allowing it to react with the carbon. So 1 gram of activated carbon has a surface area of 500 square meters. 500 square meters, that is enormous. That is just a huge, and that's just 1 gram of activated carbon. And so it's very, very, very effective at picking up things in these gas masks. The coal, to create activated carbon, and you can do this, is you can get coal, but what you have to do is you have to heat it up to 600 to 900 degrees Celsius in the absence of oxygen. So you have to get it really hot, and you cannot have oxygen source. So it's not something you can do on your barbecue because you got that oxygen source. So if you can isolate the oxygen and you get it this hot, the carbon will start to crack and it won't be They won't have anything in those cracks. Then you get it airtight and you save it in the gas masks. They're always airtight, they're vacuum sealed or in cans or something like that, so you don't have anything activating going through those pores. And that's how you make activated carbon. Kind of simple and extremely useful to purify things and to save yourself, especially when we're talking about chemical warfare. The third layer is your dust filter. It's another particle filter. Primary purpose is to collect that loose charcoal. So you don't want that loose charcoal, the last thing, you're going to be breathing that in. So that's the dust filter. So that's a kind of a simple one there. And I think we got a video on that. Yes, we do. So let's watch this video.
There we go. So that's the inside of it. Now there's one layer, I've got no idea what that is. So now it looks like I'm going to have to open up here too to get it open, so come back when I've done that. So I've gotten inside it and I've hit a little bit of a, you can't really see it on the camera, but there's all this black powder. So for my health, I'm just hoping it's charcoal, but it seems like I can't actually get any more further than this, which is a bit of a bummer because it's been like an hour just opening it and now I can't even get any further. I've got no idea. I might just risk it and get a hammer and a screwdriver and shove it in there. I've got no idea. I'll keep on trying and I'll get back to you to see if I get any further. Alright, so after about an hour of pliers and breaking up this really annoying sheet of metal with the holes in it, it turns out that the only thing in this filter is from the bottom to where the air, clean air comes out from is this, this, and this. Then all that, all that black stuff I'm guessing is charcoal because there was a lot of it. So then it would go to that weird paper stuff, which is like glued into the sides, which is really annoying. And then probably shouldn't be using my bare hands, but oh well. Then just goes to this thing that I've ripped apart with pliers with a little mesh sheeting there so charcoal or something doesn't get out, I guess. Then there was a lot of charcoal. There's actually still some in here, so and I am just praying that that was charcoal, by the way. And doesn't really look like a hard substance. It just looks like a bit of wool or fluff just to keep the charcoal from going into your lungs. And that I'll just pull the rest of it apart. It doesn't really look like there's any asbestos, or unless that white stuff with some really poisonous paper or something, I don't know. I don't really think that these filters are too bad to breathe through, but I'm still wearing the mask because I don't want to take any chances. So I'll go back to you guys when I've gotten everything out and I'll show you what it looks like. So after all that hard work, I finally pried out all the wool and the last little, I don't know, holding metal thing, I don't know what it is. So there's the inside of it. Here's the other half. It's a bit of a shame that I have to actually pry all this, so I'm going to have to like get this on top of it and then hammer with a pick or something, hammer it back in so it's all stable and stuff. But I'm fine with doing that. Now I'm just going to have to like get out all this paper, because if any of this stuff wasn't what I said and actually is or was toxic or whatever, from me breaking it up, it would be even more toxic now. So this might be a dumb idea, but I'm probably going to get like deodorant and a lighter just to like sterilize it, if you know what I mean. But yeah, and then I'll put it all back together, I'll spray it black and I'll show you guys what it looks like.
Oh, that guy cracks me up. I put those little notes on this video here as you were watching it, because I love the video because he goes through the hassle of tearing apart a gas mask filter. The funny thing about it is he has no idea what he's doing, and the comments he makes that like, I hope this isn't poisonous and stuff like that, and that just kills me because it's like, why in the world would there be poison in a gas mask? But he was right, that was carbon, but it was activated carbon. And what he pulled off here was that first layer that's catching the main particles, which could even catch anthrax, as we learned over there. And then as he tears it apart more, he gets into this area here where he says there's a whole bunch of black stuff, and he thinks it's carbon, he hopes it's carbon, he hopes it's not going to kill him because it's funny also in one there he says, I hope it's not asbestos. Why would you put asbestos in a gas filter? I don't know. I shouldn't tease him too much. I really appreciate what he did and that he filmed it because it shows us the inside of a gas mask. But I hope you enjoyed my little captions because I think it's kind of funny. Anyways, that is end for our third lesson. For my class, there's also going to be a little small reading assignment about history of chemical warfare, or an actual hero of chemical warfare, and they just recently made a movie about this guy, and his name is Sergeant Stubby. And if you'd like to go to MrRast.com and download that story, that it's pretty worthwhile reading. And I haven't seen the movie yet, but I would like to. I will talk to you guys later. I hope everything's going good and you understand what's going on here. I hope I didn't scare you too much. Thanks. Bye.